Hello. I'm going to talk about Kepler's law. With the S, right? So, first law says that this is the sun, and that's the planet. So it goes around the sun, with the sun, and this is the oval shape, so eclipse. And sun is in one of the focus, right? So there are two focus. There's one of the focus. That's not a focus. So this is F1, this is F2, right? The focus. And this is the planet. So this planet can be Earth, can be Mars, can be Jupiter, right? So let's just say this is the Earth right now, for example. Okay. So that's the first law. The first law says that the trajectory of the planets, it's an eclipse. Okay, with the sun as one of the focus. Okay, so that's the first law. So this law is strongly related to the gravity is using the form of all the UGL, right? Universal gravitational law says that the gravitational force is equal to G m1 m2 divided by, okay? It's divided by r squared. So this inverse square law, right? So this is the 1 over r squared, the inverse square law. These two are very strongly related. All right, so that's the first law. Second law, I'm gonna clear that. Second law just says the following, right? So you have the sun and the earth, or you can have, say, this is the Mars, right? So let's say that's the Mars, and the sun is on one of the focus, another focus is right there, and this is oval again. So for the same amount of the time, the duration is the same, right? So let's say this delta t from this point to that point, this point to that point, and let's say we're going this way, okay? This is the delta t, right? And when you are over here on this side, then the delta t is right there. Okay, the delta t from here to here is also delta t. I'm sorry, it's a small k, delta t. Okay, let's say it goes from here to here. Now, using the sun as not the center, but this wedge, right? Using that as the peak. So what the second law says the following is that this area that's spanned and this area that's spanned by the same delta t, okay? This delta t is the same. These two areas, if we're going to call this one here A close, right? Or close, right? And this is going to call that A far, right? So we are further away from the sun, right? So these two areas, if the delta t are the same, the second law, Kepler's second law, says that A close is equal to A far. And we will revisit this when we study the conservation of angular momentum. And also the energy can be discussed further, strong, related to the Kepler's law, but we haven't studied that, so we're going to stop here. So that's the second law. And the third law, right? The third law is a little bit more algebra, right? The third law says the following, right? So here's the sun again, and they say we have planet 1. So this is the planet 1. Oops. not quite. Okay, this is planet 1. Okay, and then we have the planet 2. All right. So the T1 is the period, right? So it goes around once, you're going to call that period. And the T2 is the period for this second planet, right? So planet 2. Okay. Well, let's say they are, in the same location, right at that time. So the mean distance from P1 to the sun, so sometime you could be here, right? So the mean distance is all the distance together and what is the average value, right? So the mean distance, we're going to call that some kind of maybe somewhere here, right? So that's the mean distance. That's S1 right there, okay? And maybe S2, it's over here, right? I mean, we just, okay? So S1 and S2 are the mean distance. S1 is the mean distance from P1, planet 1, right, to sun, okay? And S2, same thing, right, mean distance. So the third law says that T1 and T2, so as the distance, as this planet gets further away from the sun, the period will increase. But increase in such a manner that the square of this is equal to the mean distance, right? T1, S1, T2, S2, power of 3, okay? So that is your third law. So there's a relation. So as T gets bigger, then we know S also gets bigger, right? But it's not really linear. It's in this square third power relationship. Okay, so that's all we have for the Kepler 3 law, right? Until next time, all right, bye-bye.